Students, in today's class, we will learn how to integrate integral 0 to 1 tan inverse of 2 divided by x squared negative 2x positive 1 times dx. Now, you would have studied this formula, which is tan of a negative b is equal to tan a negative tan b divided by 1 positive tan a times tan b. Now, if I were to take tan A to be as some lowercase a, then capital A would be tan inverse of A. Now, similarly, if I were to take tan B to be as some lowercase b, then capital B would be tan inverse of small b. So, what I would do, I would be substituting in place of A, I would be substituting tan inverse of A. In the place of B, I would be substituting tan inverse of B. Of course, it's lowercase a and b. Now, this is equal to, in place of tan A, you substitute A. In the place of tan B, you substitute B divided by 1 positive A times B. Now, move this tan to the other side. So that would give you tan inverse of A negative tan inverse of B to be equal to tan inverse of A negative B divided by 1 positive AB. Okay, so this is the formula that we would be using over here. Now, the plan is to achieve the denominator x squared negative 2x positive 1 to be in the form of 1 positive A times B. So what I would do here is I would place 1 here followed by, now I've got x squared negative 2x, so I can take a x out and rewrite this as x negative 2. So clearly this is going to give me 1 positive, x times x is going to be x squared, x times negative 2 is going to be negative 2x. So this is the case for the denominator. Now, for the numerator, I wanted to rewrite it as a negative b. Now, clearly if I were to take x to be as a and x negative 2 to be as b, then we would have the numerator 2 to be equal to x negative of x negative 2. Clearly this is going to be equal to x negative x positive 2. So therefore 2 is equal to 2. So I have fixed my numerator and I have also fixed my denominator. So therefore integral 0 to 1 tan inverse of 2 over x squared negative 2x positive 1 times dx can be rewritten as, this is equal to integral 0 to 1. So in place of 2, what I would do is I would write it as x negative of x negative 2 divided by, in the place of x squared negative 2x positive 1, I will rewrite it as 1 positive x of x negative 2. So clearly I have achieved the representation. Okay, for my A I've got x, for my B I've got x negative 2. So this is rewritten as integral 0 to 1 tan inverse of A tan inverse of x negative tan inverse of B. So it's going to be tan inverse of x negative 2 times dx. I can rewrite this as integral 0 to 1 tan inverse of x times dx negative integral 0 to 1 tan inverse of x negative 2 times dx. Now consider integral 0 to 1 tan inverse of x times dx. I'm going to use Liet, okay, integration by parts. So I take my u to be as tan inverse of x and my dv to be as dx. So differentiating du, differentiating u would give me du, and differential of tan inverse of x is going to be 1 divided by 1 positive x squared times dx. Now I need to get dv's integration. So that is going to be, integral of dv is going to be v Integral of dx is going to be x. So my integration by parts, which is going to be u times dv is equal to uv negative integral v du, is rewritten as u is tan inverse of x times my v is x. The limits are 0 to 1. Negative integral v is x. My du is going to be dx divided by 1 positive x squared. Now the limits, I can substitute the limits. So that's going to be 1 times tan inverse of 1 negative 0. Okay, because 0 times anything is going to be 0. So this is going to be my first part. The second part, I have to integrate 0 to 1 x dx divided by 1 positive x squared. So what I do, let 1 positive x squared be equal to some t. Differentiating this is going to be 2x times dx is equal to dt. I don't have a 2 there, so x dx is equal to dt divided by 2. So this is going to be 1. Tan inverse of 1 is going to be pi over 4, so you can place that. Now integrate this quantity. X dx is going to be dt divided by 2. I place the 2 over here. Divided by 1 positive x squared is going to be t. So this is going to be equal to pi over 4 negative ln 2. Okay. So this is going to be 1 over 2 times of ln t, which is equal to pi over 4 negative 1 over 2 times of ln t. Ln t is, the t value is 1 positive x squared. So the limits are 0 to 1. So this is going to be equal to pi over 4 negative 1 over 2 times. I substitute the upper limit. I get ln 1 positive 1 squared negative. Substitute the lower limit. You get ln of 1 positive 0. So this is going to be equal to pi over 4 negative 1 over 2 times ln 2. Students, just for reinforcement, during the process of integrating integral 0 to 1 tan inverse of x times dx, we have actually obtained the formula for tan inverse of x, which has been x times tan inverse of x negative ln, in fact it's half times ln of x squared positive 1. This is what we have actually obtained, of course within the limits 0 to 1 and within the limits 0 to 1. Okay, so the most important point is this formula. Now we would be using this formula. Remember that integral tan inverse of x times dx to be as x times tan inverse of x negative 1 over 2 times ln of x squared positive 1. Of course, if you don't have a limits, you have to place the arbitrary constant c. Now when we place the limits 0 to 1, for the first part, I just mentioned to you, when you do that, you get 1 times tan inverse of 1 and then followed by negative sign 1 over 2 times ln of 1 squared is 1 positive 1. And whenever you place the lower limit, this would become 0 and this would become ln of 1. So that doesn't matter. So it's also going to be 0. So what we have got would be pi over 4 negative 1 over 2 times ln 2. So this is what you've got for the first part. Now to integrate the second part, there are many ways to integrate this, but I would just use the formula for the sake of lucidity. So integral 0 to 1 tan inverse of x negative 2 times dx. Now in the place of x, I've got x minus 2. So just substitute that x minus 2 into the formula. So it's going to be x negative 2 times tan inverse of x negative 2 negative 1 over 2 times ln of x negative 2 raised to the power 2 positive 1. So this is what you have got. Of course, you have to substitute the limits 0 to 1. Now if you were to substitute the upper limit, you get 1 negative 2 times tan inverse of 1 negative 2 negative 1 over 2 times ln of 1 negative 2 raised to the power 2 positive 1. This is for the upper limit minus the lower limit. Substitute 0. It's going to be 0 negative 2 times tan inverse of 0 negative 2 negative 1 over 2 times ln of 0 is actually of 0 negative 2 raised to the power 2 positive 1. Okay, so this is my limit substitution. So when you simplify, you get this. Now what I'm going to do is I'm going to be clubbing these two together. So that's going to be 1 over 2. I'm taking it out. I would get ln 5 negative ln 2 followed by negative 3 pi over 4 positive 2 times tan inverse of negative 2. Now ln A minus ln B, right? In fact, this is rewritten as ln of 5 divided by 2. Okay, so we can do that and then follow it up with negative 3 pi over 4 positive 2 times tan inverse of negative 2. Now we need integral 0 to 1 tan inverse of x dx negative integral 0 to 1 tan inverse of x negative 2 times dx. But tan inverse of x times dx has been found to pi over 4 negative 1 over 2 times ln 2 followed by negative tan inverse of x negative 2 times dx has been found to be 1 over 2 times ln 5 over 2 negative 3 pi over 4 positive 2 times tan inverse of negative 2. This can be rewritten as pi over 4 negative 1 over 2 times ln 2 negative 1 over 2 times ln 5 over 2 positive 3 pi over 4 negative 2 times tan inverse of negative 2. I can add these two together, pi over 4 added with 3 pi over 4, and then I can add these two together, take negative 1 over 2 out, that would give you ln 2 positive ln 5 over 2, and then follow it up with negative 2 times tan inverse of negative 2. Now these two can be added together, that would give you 4 pi over 4 and negative 1 over 2. When you use logarithmic rules, this would be ln of 2 times 5 over 2 followed by negative 2 times tan inverse of negative 2. This is pi negative 2 can be cancelled, giving you negative 1 over 2 times ln 5 and then negative 2 times tan inverse of negative 2. So this is the final answer to the question.